Thank you very much. Can you hear me okay? Is that clear? Okay, good. Marcel and I, of course, have worked actually for more than 2 years on the book that he discussed. That's been the primary focus, especially this year. This talk is mostly about a book I published last year on a climate debate between Professor William Happer and Professor David Karoly. They're on opposite sides. Karoly thinks that climate change is dangerous and all man-made, and Professor Happer has the opposite view. So I thought that their discussion, their debate, which was an email debate, was extremely rewarding for me to research it. Let's put it that way. It was extremely helpful. All right. This is the book, like I said, published last year. And in the great climate debate between Happer and Karoly, they were asked the following question by the moderator, James Barham. James was very cooperative in the book as well. He asked them, the IPCC's official position may be summarized as making 4 claims. Global warming is a well-established fact, it is anthropogenic, it is a major problem for humanity, and concerted global governmental action is required to combat it. In this talk, we will only cover a portion of the second and third parts of the question, which we rephrase as, is burning fossil fuels and emitting CO2 and other greenhouse gases to the atmosphere a good thing or a bad thing for humanity? The other facets of the question are well covered in my latest book. Most of this talk is from chapter 10. Okay, Professor Happer's response was, there is no scientific evidence that global greenhouse gas emissions will have a harmful effect on climate. Quite the contrary, there is very good evidence that a modest increase in atmospheric CO2 since the start of the industrial age has already been good for the Earth, and that more will be better. David Karoly wrote, science has established that it is virtually certain that increases of atmospheric CO2 due to the burning of fossil fuels will cause climate change that will have substantial adverse impacts on humanity and on natural systems. Therefore, immediate stringent measures to suppress the burning of fossil fuels are both justified and necessary. By science, Karoly clearly means, when you read his response, the views and opinions of the IPCC and other organizations that believe anthropogenic climate change is dangerous. Science is organized debate. Both sides present their data and analysis, and eventually one side is found to be correct by comparing their projections to future observations, rinse and repeat. Science is not a thing, a person, peer review, or consensus. It is a process. Scientific theories are validated by observations, not the opinions of scientists or government officials. The two views presented above, both by very qualified and respected climate scientists, are mutually exclusive. Which is correct? We will examine the data as it exists today, and you can decide. Observations support Happer's view. Model projections of future climate support Karoly's view in extreme scenarios. What is the cost of eliminating or curtailing fossil fuels? Is it cheaper and more reasonable to adapt to climate change? These are all good questions. Karoly relies a lot on the IPCC. Just how much warming is dangerous? They claim that 1.5 degrees over the pre-industrial or pre-1750 temperature could be dangerous, and 2 degrees C is definitely dangerous. The genesis of the 2-degree limit is flimsy and discussed by Rosamund Pierce in a well-referenced blog post at Carbon Brief. The original reference is a 1977 paper by William Nordhaus, who claims, incorrectly it turns out, that 2 degrees is outside the range of observations over the last 100,000 years. He offers no other justification for the limit. Is it okay if I talk like this or better like this? Okay. Basically, there is no scientific justification for either the 2 or 1.5 degree limits as noted in Nature by David Victor and Charles Kennel in 2014. A later report by the Stockholm Environmental Institute in 1990 admitted that setting a global warming objective or target is difficult and fraught with uncertainty. The only reason they give for setting a target is it allows one to measure progress toward the goal. They admit the goal is simply to reduce emissions from fossil fuels, but the reason this is necessary is clouded by uncertainty. Thus, a visible and firm target is needed. From the Stockholm report, where there is no universal agreement over the usefulness of climate policy targets, there is certainly not yet agreement as to what such targets should be. And this is important to remember. As far as I know, no one has any idea what the target is or if one is even necessary. The report only speculates that 2 degrees C of global warming is unusual and might be dangerous. As far as I know, this is still the case. There is no identifiable danger from 2 degrees of warming. There are 2 issues to debate. First, is Happer correct and more CO2 is better, or is Karoly correct and more CO2 will cause dangerous climate change? Second, is warming good or bad? How much warming is bad? What is the pre-industrial period that they measure warming from? The IPCC defines the pre-industrial period as pre-1750, but the global numbers it uses for the period of necessity come from 1850 to 1900 because those are the first global numbers that we have. These are the earliest global okay. Obviously, much of Europe, Asia, and North America were already industrialized before 1850. This slide shows a reconstructed temperature record from benthic foraminifera that live about 500 meters below the ocean surface in the Indonesian through flow. The reconstruction was made by Jar Rosenthal and colleagues and published in the journal Science. This is an ocean passage through the Indonesian islands that separate the Pacific from the Indian and Southern Oceans. The water temperature there mostly reflects the temperature in the northern and tropical Pacific, but they are influenced by the Indian and Southern Oceans to a smaller extent. I prefer this temperature proxy reconstruction to the various Greenland ice core reconstructions because it represents a much larger portion of the northern hemisphere climate system. That said, this reconstruction is very similar to the Greenland ice core reconstructions in both shape and amplitude. The northern hemisphere is where most people live, and it contains most long-term temperature proxies. Temperature proxies in the southern hemisphere are rare. Further, southern hemisphere temperature warming trends are much lower than in the northern hemisphere. This reconstruction shows a drop in temperature of about 3 degrees from 4500 BC, around here, to the bottom of the Little Ice Age down here. Bo Vintner's Greenland ice core temperature reconstruction also shows a 3-degree drop, and I definitely prefer Bo Vintner's reconstruction of the Greenland ice cores. The others, I think, all have serious problems, but his is very good. Attempts at hemispheric reconstructions like Michael Mann's hockey stick always understate temperature variability due to averaging disparate temperature proxies and their inevitably inaccurate proxy radiometric dates. So it appears that the northern hemisphere temperatures of the Holocene climatic optimum, right here, roughly 9,000 BC to 4,200 BC, were 3 degrees warmer than those in the pre-industrial period, also known as the Little Ice Age. The IPCC 1750 AD pre-industrial cutoff is shown with a vertical blue line on the graph. It's right here. The present day 500 meter Indonesian throughway temperature at 500 meters averaged from 2006 to 2016 is shown here. That's the present day temperature at that location. The data are from Victor Goretzky at the University of Hamburg. The Rosenthal reconstruction displayed has a value every 20 years. His estimated temperature error is about 1/3 of a degree, and the generally accepted temporal resolution is about plus or minus 50 years. So when you compare present-day thermometer-based temperatures to the past, you have to average them over some period of time that you think is equivalent. And when you're looking at very at like the entire Holocene, for example, most of those proxies have about a 100 to 200 year temporal resolution. This one is a little bit better. It's probably 20 years, at least after 0 AD. So if we add 1.5 degrees to today's temperature, we reach 9.2 degrees C. This is roughly the same temperature in the Indonesian through flow that was seen during the Roman warm period, labeled as RWP, or the temperature when Plato lived and taught. It is well over 1 degree cooler than during the Holocene climatic optimum, when human civilization and human agriculture were invented. We see no evidence that in this reconstruction that 1.5 or even 2 degrees C of warming were a problem in the past in the Northern Hemisphere. We also see no evidence that the pre-industrial period is a good standard global temperature. It was the coldest period in the entire Holocene. The Little Ice Age cold period did not occur everywhere in the world at the same time, but it was the closest our planet has been to glacial conditions in the past 12,000 years. In Europe, Greenland, and North America, the coldest time was from about 1650 to 1750 AD, coinciding with the solar Maunder minimum, a period of low solar activity from 1645 to 1715. In the Rosenthal record, the coldest time was roughly 1800 to 1815. So this cold period changed depending upon where you are. Cold spells frequently occurred during the pre-industrial period, causing humanity many problems. Paul Homewood, as well as Wolfgang Behringer's excellent book, A Cultural History of Climate, and an article by Geoffrey Parker, offer us a lot of historical examples. All over the world, most glaciers reached their maximum Holocene extent during the Little Ice Age. In Chamonix, France, they swallowed entire villages as they advanced. There was no summer during 1675, and it was the second coldest summer in the past 600 years in North America, according to proxy evidence. The winter of 1657 and 1658 was particularly brutal. Massachusetts Bay and the Delaware River both froze over, allowing people and deer to cross on the ice. The Baltic Sea froze so hard that horses and loaded wagons could cross from Gdansk, Poland, to the Hel Peninsula, 10 miles of north. Yet, the following summer was excessively hot in Italy and Greece. In India, the monsoon failed that year, resulting in a devastating famine. Between 1660 and 1680, more typhoons struck southern China at Guangdong province than during any other 20-year period in recorded history. In 1666, a hailstorm hit England, and some of the hailstones were a foot in circumference, softball size. An enormously destructive hurricane hit the Caribbean islands of Guadeloupe and Martinique in 1666 that resulted in 2,000 deaths and the destruction of a shore battery with walls 6 feet thick. Egypt in the 1670s had many very severe winters, and people began to wear fur coats, something that had never happened in Egypt before. In the 1680s, the Sahel in Africa suffered a severe drought, and Lake Chad reached the lowest level ever recorded. The winter of 1691 to 1692 was very severe, and starving wolves entered Vienna, Austria, and attacked men and women on the streets. All the canals in Venice froze over, and the mouth of the Nile River was choked with ice for a week. The cold of the 1690s caused a major famine in northern Europe, and half the population of Finland died, as well as 15% of the population in Scotland. Mixed in with the cold years were occasional summers of intense heat and drought, such as the summers of 1693 and 1694, when the heat was unbearable in both England and Italy. Los Niños were more common in the beginning of the Little Ice Age than now. Los Niños are nature's way of expelling heat from the oceans to the atmosphere to be radiated to space. This process can cause high atmospheric temperatures during the El Niño event itself, but the El Niño ultimately cools the Earth since it's taking heat out of the ocean where it can be more easily expelled to space. After the cooling stops, and that was, in this period here, when the cooling stopped, all of a sudden there weren't any more El Niños. And we didn't have any until the 20th century. We have emphasized the worst portion of the Little Ice Age, but overall it lasted from around 1300 to 1850. The first extraordinary cold weather spell of the Little Ice Age began in different places in different times, but in Europe it began around 1310 with a series of very cold and wet winters that lasted until 1330. At first the crops, though poor, were adequate, but by 1315 the Great Famine began and was followed by the Black Death from 1346 to 1352, which killed over 1/3 of Europe's population. European society had no concept of the accidental. Someone was always to blame for catastrophe. It was either a person or a group that caused it or sinned, causing God to create the catastrophe. They did not believe nature acted alone. So it was not long before Jews were blamed for the famines, cold, and floods. Thousands of them were killed. Then later, in the 1400s, it was witches, as illustrated by this 1486 woodcut. In the woodcut, we see a witch using the jawbone of an ass to conjure up a hailstorm. Over 50,000 supposed witches were killed between 1500 and 1700. The current climate consensus is not the first group in history to blame the weather on human activities. This is a recurring theme in history, as this illustration shows from Behringer's book. He labels it anthropogenic climate change. That is a brief introduction to the pre-industrial period, the IPCC's ideal climate, against which our current temperatures are always judged. The depths of the Little Ice Age coincide with the Maunder Grand Solar Minimum and the coldest part of the most recent Hallstatt-Bray solar cycle. There's always a climate rebound after a Grand Solar Minimum and Hallstatt-Bray cold periods. The real reason is why the Little Ice Age did not reach a full glacial. Why did it warm afterward? I don't know about you, but I think our current weather is a lot better than the pre-industrial. Probably the next full glacial is already baked in and will start between 1500 and 2500 years from now. Our most serious climate challenge is how do we adapt to that? Global warming is nothing in comparison. Now we have defined and explained the terms used in the question put to Happer and Karoly, And their initial answers, let's examine their views. Karoly thinks that additional CO2 emissions are dangerous because they will cause severe changes to the climate, especially global warming. We have just seen that the climate might have been worse during the pre-industrial period than it is today. Karoly does acknowledge that additional CO2 will be beneficial to plants and crops. He just thinks climate change problems are worse than the benefits. Happer delves into the details of more CO2 and how it affects plant life. On the left of the slide, we see the result of a controlled experiment by Dippery et al. 1995, using the CO2 concentration from the last glacial maximum. The plant grows very little in 14 days at a CO2 concentration of 350 parts per million. Here we go. At a future concentration of 700 ppm, much more growth is achieved. On the right, we see the results of Zai-Kun Zhu's study of the greening of the Earth from the journal Nature Climate Change. It's here. The colored areas are greener generally than they were. The period is 1982 to 2009. Zhu used 3 satellite data sets to do these estimates, and they all show that the Earth has greened considerably. The upper map uses the globe map data set. Where it shows green, blue, or pink, there is more plant cover in 2009. Where it shows yellow or red, the area has browned and has less plant cover. Most of the world is now greener than in 1982. Overall, Zhu reports that 21 to 46% of the global vegetated area is now greener, and less than 4% is browner. His simulations show that 70% of the greening is due to additional CO2. That's this bar graph right here. That's the CO2 contribution to the greening according to his model. The lower map is a simulation of the greening only due to CO2. So here we see a simulation that takes out additional nitrogen and the other factors that contributed to greening, such as land use changes. Generally, observations and modeling show that adding CO2 to the atmosphere benefits plant life, which in turn makes our life better. This is an interesting graph of global carbon emissions and corn yields from 1860 to 2020. The graph is by the CO2 Coalition. The corn yields are from Bob Nelson at Purdue, and the CO2 data are from the Appalachian State University CO2 database maintained by Gilfillan et al. It shows the correlation between rising CO2 levels and crop yields. Nitrogen fertilizer plays a role in the increase in yields after about 1980, but the general models have shown that that most of this is CO2, even up here where nitrogen fertilizer is heavily used. The IPCC claims that global warming will cause sea level to rise quicker, more extreme weather, agricultural yields to fall, and will lower the ocean pH, the so-called ocean acidification. They project that these trends will cause problems in the future, but what does the data show? NOAA's sea level graph in the top center here shows some acceleration in sea level. The period from 1880 to 1970 is very linear, with sea level increasing 34 millimeters per century. From 1971 to 2022, the rate is 59 millimeters per century. An increase, but still not very scary. After all, the daily tidal range in the open ocean is 600 millimeters and much higher in many coastal areas. Right of the NOAA sea level graph is a graph showing sea level rise since the last glacial maximum. It shows that sea level rise has been much higher in the past, especially prior to 5000 BC, during the Holocene climatic optimum when human civilization began. Weather-related disaster costs as a percent of global GDP have been decreasing rapidly for the past 30 years, as shown by Roger Pielke Jr.'s histogram on the lower left. He has also plotted the total number of climate or weather-related disasters from the EMDAT database since 2000, and the total number are also decreasing. This is not surprising. Nights are warming faster than days, and winters more than summers. In short, the weather is becoming milder with time, less extreme, not more. Finally, as Bjorn Lomborg has shown in his 2020 paper, the number of climate and weather-related deaths has fallen dramatically since 1920, when non-climate-related deaths due to natural disasters have dropped much less. In short, there's no evidence that sea level rise or extreme weather are problems today. This slide examines the exchange between Happer and Karoly on ocean acidification and agricultural yield trends. The left graphs show the worldwide trends in cereal production and the number of food calories available per person since 1961. These two here. Both are increasing in nearly linear trends. In previous slides, the correlation between increasing CO2 emissions and yields since 1860 was striking, and Zhu estimated 70% of the increasing plant growth is due to increasing CO2 and warmer temperatures. Most of the remaining greening is due to fertilizer and mechanization of farming. Ocean acidification is a misnomer. The ocean surface water pH is about 8.1, which is basic, not acidic. Aerially, pH varies from 8 to 8.25, depending mostly on latitude. It is a bit lower in the tropics and a bit more basic at the poles. The pH typically decreases with water depth, proximity to land, and with the seasons, and can reach values as low as 6, truly acidic, in rare natural environments. All shelled animals and fish have built-in defenses that protect them from changing pH in this natural range. The decrease in pH since 1770, presumably due to CO2, is about 0.11. The highest change is in the Arctic, where it decreased 0.16. These are very tiny changes, and fish and shelled animals live through these sorts of changes every day from noon until midnight. The pH varies on the ocean surface from daytime to nighttime more than the average has changed since 1770. When CO2 is absorbed by the ocean during the daytime, it is rapidly taken up by phytoplankton for photosynthesis. At night, when the phytoplankton respire, the pH drops by about 0.7. Obviously, the fish in the water have no problem with this. As shown on the right of the slide, some dead pteropods will corrode when they fall to the ocean floor. The ocean floor can be corrosive. This upper figure was presented in the debate as evidence that decreasing pH is dangerous to shelled animals. This is only true if the shelled animal is already dead. A living pteropod is shown below the dead ones, and it is fine because it has a periostracum that adjusts the pH in the region where the living animal makes its shell. The periostracum can handle external pH values from well over 8.3 to 6 with ease. No pH values outside these ranges are projected. As for the Australian Great Barrier Reef, it now contains a record amount of coral. The reef is fine and not in danger. Okay, the economic consequences of global warming and increasing CO2 were only touched on in the debate, But we want to mention the work on climate change economics by Yale professor William Nordhaus. Nordhaus won the Nobel Prize in Economics in 2018 for his work on climate change, the economic impacts of climate change. The graphs in this slide are from his Nobel Prize acceptance lecture given in Sweden in 2018. His analysis of the IPCC estimated total costs of global warming in green, I'm talking about these green bars over here, and the cost of reducing or eliminating fossil fuel CO2 emissions in red shows that the optimum economic global warming path is the orange line identified with triangles to the left. That's this one. So this is his economically optimum scenario, using a rather extreme CO2 emissions model, I might add. So the y-axis is increasing global temperature in degrees C. His optimal path warms 4 degrees by 2130. The right-hand graph compares the cost of reducing fossil fuel use in red to future costs due to preventing warming in green, as estimated by the IPCC. The optimal scenario is compared to a base case in which nothing is done, and cases where mitigating CO2 emissions are done to keep warming below 2 and 1.5 degrees over the next 100 to 200 years. What this means is this is a 200-year time to get to 2 degrees of warming, 100 years to get to the same target, and this is the cost of 2 degrees and the cost of 1.5 degrees, 100 years. Nordhaus chose an extreme global warming scenario, one that does not agree with observations, as we will see in the next slide. Thus, you are looking at an analysis, really a very much of a worst case scenario, of possibly inflated costs due to inflated projected warming. Nonetheless, it is clear we cannot afford to reduce fossil fuel use to limit warming to 1.5 to 2 degrees. Nordhaus says that himself. Okay, this is a slide talking about scenarios. We see on the right, we see a realistic assessment of various IPCC CO2 emission scenarios. The summary is from an article in Nature in 2020 by Zeke Housefather and Glenn Peters. Neither of these scientists are anywhere close to being a skeptic or a denier. But they are very mainstream and are upset that the extreme and very unlikely RCP 8.5 and the newer AR6 SSP 3-7 scenarios are being portrayed in the media as business as usual. They both represent an unlikely high-risk future that has been discredited in the peer-reviewed literature. As I note here, these two are what they're talking about. And this is the one that was used by Nordhaus. Nordhaus's optimal scenario is like the second from the top, labeled unlikely, where temperatures reach 4 degrees C by 2100. Recent observations are well below this scenario and follow the RCP 4.5 scenario. To provide some geological context, we show the RCP 4.5 level of CO2 in the year 2100 on a plot of CO2 concentrations for the past 500 million years. As you can see, this level of CO2 was exceeded between 50 and 20 million years ago around the Paleocene-Eocene thermal maximum, or PET-M, when temperatures were probably 10 degrees warmer than today. This was also the time when our ancestors, the early primates, evolved and spread widely around the world. Primates, other mammals, new species of turtles, lizards, and many plants evolved and spread widely during this period when global temperatures were 10 degrees warmer than today. Is CO2 good or bad? In summary, currently we have observed no, I emphasize no, negative effects from rising CO2 or global warming. In fact, if anything, the world is better now than it was during the pre-industrial period. We have fewer weather and climate-related problems. Agricultural productivity is higher. There are credible models that ascribe these improvements to rising levels of CO2 and warmer weather. The global economy is currently growing at about 3% per year, and no one expects that growth rate to change much. At that rate, the economy will be 1,000 times larger in 2100 than today. A 2% growth rate, the historical average, results in 478% growth in global GDP by 2100. The IPCC estimates that this will be reduced by 3% due to climate change, meaning we would see 464% growth rather than 478. The question is, would anybody even notice the difference? In the meantime, we will radically destroy our economy today by eliminating fossil fuels to save 14% growth in 2100. Is this smart? That is the question we need to ask ourselves. Nordhaus claims that the optimal economic scenario leads to 4 degrees of global warming. Current realistic projections say we might see 2.5 to 3 degrees of warming in 2100. So what's the problem? More than 6,000 years ago, temperatures were at least 3 degrees warmer than today in the northern hemisphere when civilization began. We can say that because the ice cores in Greenland say 3 degrees, and the Indonesian thruway, 10,000 miles away, says the same thing. All Karoly and the IPCC have are ominous projections of future warming with further projections of damages based on them. None of their projections have been validated, and they have been invalidated by Ross McKittrick and John Christie in 2 recent critical papers published in 2018 and 2020. Calm down, folks. There's nothing to worry about. And that's the end of it.